So far, so good.
Okay. Now let's see. We're having a session tomorrow also?
No.
Oh, tonight instead of tomorrow. Okay.
Right.
Okay. So it looks like we're covering a variety of things here. We got arithmetic series and sums. Looks like you've done those correctly. In part D, where it said explain why she cannot organize them in a triangular pile, what's the explanation?
Once I figured out what X is, since looking at the answer, it probably wouldn't be an even number.
Right, it's got to be.
Explain that you cannot have part of a can at the bottom.
Exactly. You also would not be able to arrange 4 cans in a triangle.
Right.
Okay. And the way you determine that is when you go to solve for it, it comes out to not be an integer. If it's not an integer. In other words, up here, it was an integer.
Right.
Down here, it's not.
Right. So I know that one.
Okay.
I just didn't finish it in class.
Okay. So number 6. What is the value of f prime of 1?
Zero?
Yeah. What's f prime mean?
The slope of the tangent.
Right. It's the first derivative, which means the slope. It's whatever the slope of this function is at when x is 1. And we can see that the slope is 0. So what's f prime of 3?
Negative 1/2.
Uh-huh. Yeah. All straight lines have the same slope throughout their line. So if the slope here is negative 1/2, it's negative 1/2 there, and it's negative 1/2 that whole way. What would the slope of f of minus, I know they're asking about 3 times the f of minus x, but let's just talk about f of minus x. What would that look like?
It would look like a point at 0, 0, a point at negative 1, 1, a point at negative 2, then positive 2.
Yeah, it would be a reflection of that graph about the y-axis.
Right.
That's what the consequences of f of minus x is always going to be, is it's a reflection over the y-axis. So if we take this curve, reflect it over the y-axis like you did, and then what's the consequences of the 3?
It would multiply the x,
Yeah, it's a vertical stretch. It's a vertical stretch factor. So instead of the point being right there at minus 1, 1, it's going to be at minus 1, 3. And we can draw a series of points and connect the lines, and that would be our curve.
Actually, it'd be at 0, negative 3, since it'd be reflected, right?
No, we're reflecting over the y-axis, not the x.
Oh.
In other words, a reflection over the x-axis is when you have minus f of x.
Ew. Okay.
Okay. Here,
so
let me make sure.
Then in that case, it would be
oh, I see. All of those points you read me earlier were reflections over the x-axis.
No, I spaced for a moment and didn't realize f of x was what was drawn. I was just doing it just of a regular function.
Okay, so this is f of x, right?
Uh-huh.
So if I reflect that over the y-axis and vertically stretch it, it's going to look something like that.
Right.
Okay. Oops, wrong page. Okay. what is the graph of y equals f of 2x going to look like?
A horizontal stretch?
Is it a stretch or a scrunch?
Scrunch.
Yes. In other words, when you're doing stretching, like in the previous one, if this number is greater than 1, it's a stretch. If it's between 0 and 1, it's a shrink. When you're doing horizontal stretching, it's the opposite. If this number is greater than 1, it's a shrink. If it's between 0 and 1, it's a stretch.
Ah.
Okay? Similar to a sinusoid function. Where b is greater than 1, it ends up compressing the sinusoid function, not stretching it. So in other words, we would take this and scrunch it up so that it would look horizontal to that point and then slanted to that point.
Right.
Okay. All right, let's go to the next page. When it says sketch the graph, how does it want you to do that? Just plugging in points for x and figuring out what y is? Or
they want to have the specific information that they give you and get the general shape after that.
Okay. Well, I asked because they don't want you to do it on your calculator or on a computer, right?
Right.
Okay. So we can certainly plot point P. If we assume this is the origin here, or did you assume the origin was in the middle of this graph, or?
Yes.
Yeah, okay. Well, we'll put it there then. So when x is 0, y is 1, so that's our first point. And then I presume you're going to figure out when x is 1, what y is 2 and 3. Plot those 3 points and connect the dots. Is that what they want you to do? Or do they want you to figure out the maximum point Q and plot just P and Q? I mean, in order to sketch, here's what the graph looks like. Okay, right here. The y scale is not very big, but we can see that when x is 0, y is going to be 1, and then it comes back towards the x-axis as you go from 0 to 3. Okay? And you can also see that in that interval, somewhere in there, we're going to have point Q that is the maximum. How do we figure out Q? Let's figure out Q first before we try to graph this thing.
Yeah, I think that's what it's asking.
Okay. So, in order to figure out the maximum point of this function, what do we have to do?
Find the derivative.
Okay, which is the next step. In other words, we have to actually do step B in order to solve for step A. We can't label Q until we know where it comes. They didn't tell us where Q came. So the only way we can figure out where the maximum is on that function is by taking the first derivative and then what?
And then plugging in 0 for x?
Not for x.
I mean y.
For f
for
prime
y.
of x. In other words,
f prime of x.
f prime of x is going to be the slope, okay? And we know that that maximum comes when the slope of the tangent line is 0. Well, it's hard to see in this. I apologize for that. I don't have the version of Wolfram Alpha where I can scale it myself. But you can tell that wherever this maximum is, it's going to have a horizontal tangent point. By definition, basically. So, how do we find what value of x gives us an f prime of x that's equal to 0?
First I have to show, okay, anyway.
So we've got 0 equals 1 minus 2x times e to the minus x. Now, we can do this either way. We can, first of all, solve this, and then go back and figure out how we got f prime of x, because I know you got to show how you get this.
Right.
But in order to find q, we're going to do this. And we'll do it in either order you want.
Oh, wait, hold on. For B, part 2, that's when they want me to find the exact coordinates.
Well, for A, it says label the points P and Q. How can we label Q without knowing its exact coordinate?
I mean, it doesn't say no graphing calculator.
No, all right. It doesn't really matter. In other words, we're going to do all of these steps. Let's go ahead and take the first derivative. Let's start there. Since we have to do B at some point. I mean, I know the IB program is rather specific about how you solve these problems, as I found out last time. And that's fine. I have no problem with that. Incidentally, I was wrong on that quadrilateral. I hope you didn't get dinged for it. After our session last time, I went in and sat on the couch and I started thinking about it, and I realized that was an ambiguous quadrilateral. There were 2 different quadrilaterals you could draw. And so I called you back. Then I came down and I looked at the problem again, and it says name the obtuse angle. And one of the quadrilaterals would have had an obtuse angle, one would have had an acute angle. So it wasn't ambiguous. They were telling you that it did closely fit their drawing. Although I should add that you can't look at the drawing. In other words, much like you are given a triangle with 3 dimensions, they don't draw a triangle for you. They just say angle A is 30 degrees, side A is 8, side C is 10. Okay? So you can define a quadrilateral the same way. So they could have defined that quadrilateral. It would have been a much better problem had they not said come up with the obtuse angle. Had they just said come up with the angle, then you could have showed your brilliance by showing them that there's 2 possible solutions. So in a way, I was a little disappointed that they asked for the obtuse angle, because that made it a much easier problem. You didn't have to worry about the ambiguous triangle that way. All right, getting back to this problem. How do we take the derivative of that?
We'll do a product form. So
product rule.
1d2 plus 3d1. I mean, yeah, product rule.
Okay.
So it'd be the quantity of 2x plus 1 times, would it be negative e to the negative x?
Yeah. So I'm going to put a negative sign in front of that. E to the negative x, like that. Okay? Plus what?
Plus e to the negative x times 2.
Okay. Now, how do we turn that thing into what we see there? In other words, let's simplify this. What's the first thing I'd want to do to simplify this?
Well, you can distribute e to the negative x into the 2x plus 1.
You could. That's probably not the most direct way to simplify it, especially if I'm trying to simplify. If I know what I'm trying to simplify it.
You could pull out an ex, e to the negative x, out of the entire thing.
That's the best way to go. In other words, let's factor out an e to the negative x leaving behind this 2 and,
negative.
well, that 2 is plus. This becomes minus 2x minus 1.
Right.
Which becomes e to the minus x times 1 minus 2x, which is the answer they have there. Okay? So we know how to take the derivative of it. Now we're going to set that derivative equal to 0. And how do I solve for x? In other words, if I have 1 minus 2x times e to the negative x, if that's equal to 0, how do I solve that?
Well, the first way to do it is, since 0 times the number 0 would be the 1 minus 2x, and set that particular one into 0, so that way you could get x equals
1/2.
Right.
What's the other solution?
The other solution would be using logarithms to figure out
Well,
e to the negative x.
let's talk about that for a moment. So if we're going to set e to the negative x equal to 0, is there any way you can take a positive number, which e is, take it to any exponent and make the result 0? No, there isn't.
No.
In other words, if I take the number 2.71, no matter what exponent, I could take it to the minus 100 exponent, and it's not a negative number even, let alone 0. In other words, I can't make e to the minus x equal to 0. That's impossible. So there's only one solution here, and that's x equal to 1/2.
Right.
Okay, so if we want the coordinates on point Q,
Then we plug 1/2 into all
which equation?
f of x.
Right. So what is that? When I make that 1/2, that becomes 2e to the minus 1/2, or 2 over the square root of e. I don't know which answer, what form they want you to put it in. Actually, I prefer that form right there myself. Although that has a negative exponent. Sometimes they don't like you to put negative exponents if you don't have to. So I could do it like this.
Do you think they'd be okay with right? No.
Ah, you know what? They might want to rationalize that. In other words, that actually has an irrational denominator. And we could get rid of it by multiplying this by e to the 1/2 over e to the 1/2. So actually the best answer is probably that. Because that is a fraction. No, it still has an irrational number as the denominator. So that doesn't help. Now, whenever you're dividing by pi or e, you're stuck with an irrational denominator, whether mathematicians like it or not. In other words, there's no way to rationalize this if I had 2 over pi. I can't rationalize that.
Right.
So you just have to live with it, which means that any of these answers is as good as the other. This might be the best answer, but that certainly is okay also. So the coordinates on Q are going to be
1/2.
right there in parentheses.
Right.
Okay. So that was part B. Find the exact coordinates of Q. Okay, I still can't quite figure out how they expect you to do A without doing B first, but All right. C, I've looked at C for quite a while, and I don't have a clue as to what they're talking about. Maybe you can explain it to me.
Which part?
C, it says the equation f of x is equal to k, where k is a subset of all reals.
Right.
And it has two solutions. Write down the range of values of k.
Maybe it's 0, right, 0 is less than or equal to k, which is less than or equal to 3, because that's the domain of the function.
What's the thing about the two solutions?
I don't know.
Has two solutions. Now, the only progress I was able to make was making the function equal k, since they say f of x is equal to k. Well, f of x is this. So I tried starting with 2x plus 1 times e to the minus x. That's f of x. They're saying it's equal to k. And k can be anything, all reals. It's part of the subset of all reals. So it doesn't have to be an integer. Doesn't have to be anything. I guess in this equation, k has to be positive. In other words, as long as the domain is restricted from 0 to 3, this is always positive, and this is always positive. So two positives equal a positive. So we could certainly say k is positive. It's two solutions that I'm mixed up, I'm confused by.
Maybe they mean by plugging in 0 to f of x, finding that value, and then plugging in 3 to f of x, and finding that value, and that would be the range.
So I plug in 0 for x. So when x is 0, f of x is e to the minus x. When x is 3,
Actually, wouldn't it equal 1, since negative e to the 0 would be 1?
Yes, sorry. Thank you. And then f of 3 would be 7 times e to the minus 3. Still don't know what they mean. Tell you what, since we only have 7 minutes, let's cover this last part here, the last two parts, because they're going to take 7 minutes all on their own, rather than wasting time on the part that I'm not sure I know how to help you with. Okay, so they give us the second derivative. Show that the curve of f has only one point of inflection. Well,
So would I do a number line?
Nah, we don't even need that. The point of inflection of f is going to occur when the second derivative is equal to what?
0.
Okay. So, again, we're faced with that same exact situation where if I set this thing equal to 0, e to the minus x can never be 0, so 0 must have to come from this part of it. So the inflection point is going to occur at positive 3 halves. When x is equal to 3 halves, we're going to have an inflection point, and that's the only place, because there's only one point where that's equal to 0.
Right.
So that answers D. Now, I'm going to approximate this curve just for points of illustration here. Our curve looks something like this. Yeah. Well, and it doesn't actually touch. Let me redraw it. We know it goes through, one day I'll learn how to draw a horizontal line. We know it goes through this point here, and we can see from the Wolfram alpha that it does something like here. We know there's a maximum at a half, and then it's actually asymptotic with that line. Okay, and I'm going to put 3 on there. And they said there's P, and let R be the point on the curve with an x-coordinate of 3. So this is R. Okay? And they want the area between the curve and that point right there.
Would I have to integrate it?
Would you have to what? Yeah.
Integrate.
We're going to have to integrate it, and we're going to integrate f of x minus the function that represents PR. In other words, when you're finding the area between two curves, that's the way to do it. It's the top curve minus the bottom curve.
Right.
So, I got 2 ways I can go. Integrating the top function, that's going to be relatively straightforward. I can come up with an equation of PR, relatively easy. I know where P crosses the y-axis, and I can figure out what its slope is. If I can figure out its slope and its y-intercept, then I'll have the equation for it. And that's what I'll put right there. Okay? Let's see if we can come up with it. We'll come up with it in this format. And we know what B is, 1. What's the slope? Rise over run. So the rise is going to be f of 0 minus f of 3. Is that not the rise?
Oh, right.
Divided by the run,
oh, okay.
Which is 3.
Right.
Okay, so the equation of line PR is y equals, well, f of 0 is 1. 1 minus, what did we say f of 3 was? Didn't we have to figure that out? I actually did figure it out at some point, didn't I? No. F of 3 was 7, was it 7? 3 is 7 times e to the minus 7th. 7 times e to the minus 7th. There's our rise.
Right.
All divided by our run. So there's the slope. So I could say the equation of line PR is that number, x plus 1.
Huh.
Now, there's a little easier way to do this, and that is to find the area under this curve, between the curve and the x-axis, which is relatively straightforward. You just integrate f of x from 0 to 3. right?
Right.
And then figure out what the area of this trapezoid is. Well, the area of that trapezoid is not a whole lot different than what we just had to do. We're going to take this length plus this length divided by 2.
I can't see it.
Okay. You know the formula for an area of a trapezoid?
Yes.
It's 1/2 base 1, this is base 1, plus base 2 times its thickness, 3. Okay, we know base 1 is 1, and we know base 2 is 7 times e to the minus 7th, whatever that number is. So we can figure out the area of that trapezoid and subtract that from the other, and that actually makes the math a little easier if you do it that way.
Right.
But I thought I would point out both ways. And I hate to run, but I do have a 7:30 tonight, so I'm going to have to run without having figured out what that 1K means, but hopefully you'll figure it out.
I'll send.
Oh, I didn't even see problem 8 was on here either. Oh, that's a whole nother problem. You sure you don't want a session tomorrow night?
I'll be in Fort Collins,
Okay.
so technical difficulties.
Okay. I will talk to you, let's see, we're going to be on next Thursday again?
Yes.
Talk to you
I
next
believe so.
Thursday.
All right. Bye. Thank you.
Bye.